Hey there. Today I was working with this art disease prediction dataset. So I just thought of, explaining this to you. This is a really easy uh, dataset to work with. So as you can see, wait a minute. Yeah. As you can see, I mentioned day 7 because I'm on a challenge where the name of the challenge is 30 days machine learning project challenge. So today is day 7 and I completed it. And after completing each project, I write. Sorry, there was some interruption. So after completing each project, I write a blog about that project like this, and I explain the codes. And if you're someone who is just getting started in machine learning, or you know a few basics about machine learning, I would recommend you to just get started by doing simple project like this, which will really, expose you to different concepts and makes you understand the workflow of a machine learning project from, loading the data, pre-processing, then handling missing values and handling categorical variables, numerical variables, scaling them, you know, changing the categorical variable into numbers using like uh, ordinal encoder, one not encoding, and a lot of stuff like that. So I'm getting out of topic. Let me explain you this. So I imported pandas as P. People usually import pandas as PD. I know that. I thought of trying it differently, so I used P. Then I imported it as you need to download it first. Clicking here, and it will give you a zip file. You need to extract it and click on this, and you can upload the CSV file using this. Then you can load it. Then when I give df.add, it will give me the first 5 rows of the dataset. As you can see in our dataset, everything is just numbers, and this is like this column right here. The art disease is the only categorical column that we have, and that is also our label, or you can also say target. And every column other than that is our features. Using these features, we are going to predict this. So then, you know, I used df.shape, which will give me the number of rows and column present in the dataset. Then df.info method will give me all the details about the dataset. So this it says that it gives me the d type, and if there is any how many non-null values are present in the dataset. As you can see, there seems to be no null value present in this dataset. We can also check that using this. If I do something like df.isNull.sum, it will tell me if there is any null value present in any of the column. So there is no null value in any column. As we have seen, there is like this category column need to be converted into numbers. So to do that, I'm going to use this replace method and replace the presence with 1 and absence with 0. Then the df.tail, I just use this to get the last 5 rows. Ignore this. As we don't have any null values in our dataset, we can just split it into features and labels. This is our label which we want to predict, and this is the features which we will use to predict. I have not you know scaled or converted. I mean, by scaling, I mean, as you can see in this row, we have values like ranging from 100 to 120 and stuff. And even if you choose this column, we have values ranging from 1 and 4. So these numbers, vary a lot. So when we need to convert these numbers into a standard, all these numbers should be in the same range. That's what we call scaling. But as we are going to use models like decision tree, random forest, and XGBoost. I didn't use this model, I just imported it. Ignore that. We don't have to scale. If you want to, you have to scale when you're using models other than this three. So I didn't scale, I just did this, separated the features and labels. Then I created a variable models and placed all the models inside a list. Before that, I what I did is, instead of using train test split, I used something called cross val score. What this will do is, this will divide the dataset into like five folds. As I mentioned, five here, it will divide the dataset into five and trains it with the first four and test it with the last one, and it repeats this five times. To explain this more clearly, you can learn cross validation from here. This is a great course where you can learn cross validation from. I will show you a diagram so that you can easily understand. Yeah, here it is. It will first divide the you know dataset into five folds like this, and it uses the last four for training and the first for validation. Then it uses this for validation and all other this for training, and so on. It does this for five times. This is like a great book from which you can learn. And after getting, we will get five values, right? After getting these are the five values we got for decision tree. If we take the mean of this is what we got. This is saying us that our model, the decision tree classifier model, is giving an accuracy of 74, which is not that bad. Let's also test other models. So I created a for loop and tested each model one by one, and I got 83 for random forest and 78 for XGB classifier. Then, as you can see, we got some good accuracy for random forest classifier. So I picked the random forest classifier and thought of improving it further by giving providing it hyperparameters. Now I used train test split and splitted the dataset into train and test sets. Then I imported the grid search CV, which will automatically provide different parameters to a model and test which is the best parameter that is giving the highest accuracy. And and I asked which is the best parameter. It says the max depth equal to 10 is giving good accuracy. So I created a random forest model using max depth 10 and trained it. Ignore the noise, sorry for the noise. And then I predicted it using the X test and imported the accuracy score to test the accuracy of the RFC model, and you know used the accuracy score and passed the original value and the predicted value. And now the accuracy score is stored in RFC score. RFC score is nothing but random forest classifier score, and I printed it. Now I get 87, which is really good. And that's it, guys. I was ranting. Sorry for that. I was just, trying to explain this really easy, project or dataset to work with. Try it yourself. Thank you.